Okay, so today we will proceed to our next chapter, which is road loads. Road loads in terms of aerodynamics, rolling resistance, and road slope. Okay, for introduction, for the first road loads, which is aerodynamics, this term makes major impact on modern cars and trucks through its contribution to road load. And then these aerodynamic forces interact with the vehicle, which cause the vehicle to have varies of forces and movements. For example, drag, lift, uh, lateral forces, moments in roll, pitch, and yaw. And it's also contribute to the noise around the vehicle. Aerodynamics also will impact the vehicle fuel economy or fuel efficiency, the handling and NVH of the vehicle. Okay, as you can see, uh, your notes, okay, there is a sports car and then there is a flow, uh, airflow, airflow around the car, airflow around the car, okay. For example, the airflow from left to the right, okay. This flow we call it streamline, streamline. Normally we streamline. Tengok dia punya flow punya pattern, okay. And then also the flow underneath the car, right? How it come out. Okay. Objective why we need to study the aerodynamics of the vehicle, because we need to improve the flow past the vehicle bodies, such as we can reduce the fuel consumption, we can make more comfort to the driver, such as to reduce the noise, and then to study the ventilation or cooling effect of the passenger compartment, and also to reduce the mud deposition on the vehicle body. On top of that, we can also improve the driving characteristics such as stability, handling, and traffic safety. Okay, in the vehicle aerodynamics, you need to study the flow in three sections or three areas. First is flow past the vehicle body. Secondly, flow past the vehicle compartments such as wheels, heat exchanger, brakes, and windshield. And also inside the vehicle, flow within the passenger compartment. Okay, normally this one study the air conditioning inside the vehicle. Okay, mechanics of airflow around the vehicle. Okay, the aerodynamic forces produced on a vehicle arise from two sources, which is pressure or drag and viscous friction. Okay, and it lies on the Bernoulli equation. And then if the flow is incompressible, the equation is this. P stands for pressure, meaning that the total pressure is equal to static pressure plus dynamic pressure. Static pressure, the symbol is PS, and then the dynamic pressure is related to the density of air and also the velocity of moving air, which is relative to the car. Okay, for example, the car travels from right to the left, and then the airflow is relative. Maksudnya dia bertentangan against the vehicle punya travel direction. Okay, for pressure and dynamics term, this is the formula. Rho times V square over 2. Okay, so in total we get the total pressure. And then for rho, or density of the air, this is the equation. Okay, please be in mind, for example 100, yang ni bukan comma, point. 100.325. Ni 288.16. Nanti saya betulkan dia bukan comma, point. Okay. PR is the atmospheric pressure in kilopascal, and then TR here is the air temperature in Celsius. So this is the total pressure that exists when aerodynamic force is available. Okay, like I mentioned before, the Bernoulli equation states that the static pressure plus the dynamic pressure will approach the vehicle. Okay, and then if you can see this figure, okay, for example in wind tunnel, when we make the experiment, the vehicle is in static. Okay, only the airflow will flow through the vehicle. Okay, for example, this line go through the vehicle. Okay, we call it streamline. Streamline. So there are many streamlines here. And then a bundle of streamlines, we call it a stream tube. Stream tube. For example, at this area that faces the center of the vehicle and goes up of the vehicle, we call it stream tube. Stream tube. Okay, and then just fundamental theory, how the air flow through bodies. Okay, for example, we have ball, sphere ball. Okay, and then this is the flow from left to the right. Okay, for example, I take one streamline, this one. Okay, the air flows to the bodies, okay, and then come out. Same goes to here and here. Okay, so at here, this area, the velocity will in high velocity. Sorry, in low velocity, but the pressure is high. At this area, its pressure is decreased or small, but the velocity is high. Dia terbalik, dia against. If pressure is high, velocity is small. If pressure is small, the velocity is high. Okay, and then because of this sphere, okay, upper region and lower region is same. Okay, same. Okay, and then how about the flow? Okay, we have here is one object, right? Okay, they are infinity flow here from left. Okay, when it touch this body, it will create a laminar flow until this region. This is the laminar flow. and then after that it will transition to the turbulence. It's turbulence. This area is turbulence, and then this height we call it boundary layer. Boundary layer. And if the flow, for example, we take at the rear of the car, the flow will have a turbulence here, and then we'll have a separation. Yeah, separation here. This is called separation point, and then the flow will like this at the rear of the car, for example. Okay, so when we look into this figure again, okay, the flow around the cylindrical body, okay, it will cause this like this pattern, this pattern, and then we have some vortex here at the back of the body. Same goes to we can apply to the vehicle. The flow from the front of the vehicle goes around the bodies, okay, and then at the rear of the vehicle there are vortex that will be created. Vortex. Okay, any question until now?
No, sir.
No, sir.
Tak ada, sir.
Ada. Okay.
Tak ada.
Alright. So saya continue. Okay. The aerodynamic forces exist in different ways, depend on the direction of the air. Okay, direction of the air. Okay, for example, a vehicle in longitudinal axis. Okay, longitudinal axis. Mana longitudinal axis. The aerodynamic force will act in opposite direction of the vehicle travel position. Okay, and then the value will be positive in rearwards direction. Okay, kita panggil dia drag force lah, drag force. And then kalau ada moment kat sini, maksudnya rolling, dia pun akan ada effect lah. Same goes to lateral direction. Okay, y-axis. Here, lateral direction y-axis. For example, ada side force lah. Side force. The value will be positive to the right. Okay, positive to the right. And then, of course, kalau ada side force, dia ada pitching lah, moment dia. And then vertical, kita tengok vertical sini. Positive, we can treat as positive. Kita bagi dia lift. Force nama dia lift. Lift. And then kalau moment tu, dia ada moment yawing lah. Okay. So, we go to kita tengok effect of the components inside the vehicle. Okay. Okay, for example, there are two types of vehicle, namely fastback and hatchback. Okay, fastback ni like sedan lah, like sedan. Hatchback ni hatchback lah. Okay, and then we look into the graph here. Change of drag coefficient, CD, and delta CD versus the slope angle. Okay, slope angle. Slope angle is the angle between the inclined face at the rear and the horizontal top of the vehicle. Okay. This is the slope angle. Okay, as you can see, okay, slope length. Okay, LO. LO is the rear punya dimension to the end of the vehicle over L, over the length of the vehicle from front to the back. Okay, as the LO increase, LO increase, meaning that the drag, change of drag coefficient is will be increased. Okay, will be increased. Tengok graph ni kan. If LO is small, okay, small meaning that hatchback lah, hatchback, and high value of LO meaning that sedan, sedan. So sedan will create more change of drag coefficient. Okay, we will look into this graph. Okay. Next, we look into the front of the vehicle. Okay. Kita tengok macam mana drag component. Okay, for example, how to minimize or how to control the aerodynamic drag. Okay, and then this example is for four-body drag that influenced by the design of the front end and windshield angle. Okay, kita tengok kat front end dia. ZS is the stagnation point height, starting from here until kita tengok this shape up. Tengok dia punya shape punya variation. Okay, and then this graph is ZS over ZV. ZV is the vehicle height. ZS is the stagnation point height. Okay, if the ZS increase ni, the change of drag coefficient will increase. Increase until some point. That will be decreased. Okay, so how to minimize the drag? When the stagnation point is kept low on the frontal profile of the vehicle. If we keep the ZS low as soon as possible, destination point, so we can get the minimum drag. Okay, and then how about the windshield angle? Okay, we can see here when we increase the windshield angle, this angle, okay, it will contribute to the increasing of the drag coefficient. Okay, and then we look into the aerodynamics aids. Aids maksudnya apa yang mempengaruhi aerodynamics punya forces. Okay, first we look into the window and pillar treatment. How we can reduce the aerodynamic drags by modification of some area of the vehicle. Okay, for example, here there are several areas that we can improve. Okay, A, B, C, D, E. There are 5 areas. Okay, for example, A is, we call it air dam. B is the hood line. C is the A pillar shape. D and E is the D pillar shape. So normally the engineers or technologists will create will do a design and do the optimization of the design to reduce the drag. Okay, for example, they will make the sharp edge to be round. Okay? For example, round, no sharp edge, and then increase some measurement here. For example, at B area, okay, at D area, and then it will cause the drag coefficient to reduce. Okay? For example, initially this vehicle has 0.5708 punya coefficient and drag coefficient. So if we implement the modification or optimize area from A plus B, A plus B plus C, A plus B plus C plus D, and finally plus E, the CD will decrease. So, for example, this one is the optimum form. Optimum form that the vehicle has CD is around 0.33. Okay. And then on top of that, by have spoiler at the rear, okay, that will deflect the air upwards here, and pressure will increase, creating a downforce and reduce the rear lift. Macam kita tengok F1 car kan, siapa yang pernah tengok F1 car, sebelah belakang dia ada rear, bukan rear spoiler, apa rear punya ni lah dia punya aerodynamic X. Maksudnya dia akan reducekan vehicle to reduce vehicle punya rear lift. Maksudnya vehicle tu akan ke bawah to the ground. Okay, and then this is the CD, the aerodynamic drag coefficient. Okay, kita tengok sebelah sini dulu. This upper figure. The CD varies, depends on the object. For example, the flow will come from the left to the right. Okay, if flat plate, the CD is around 1.9. If the hemisphere, CD is around 1.42. Hemisphere other direction, 0.38, and airfoil is 0.007. Okay, so airfoil shape is normally applied to the aerospace industries, to reduce the aerodynamics drag. Okay, and then this type, there are several types of vehicle and their CD. Okay, when we compare truck and vehicle, they are different CD. And then this equation is the aerodynamics punya drag. Aerodynamics punya drag equal to rho V square times drag coefficient plus A times A. A stands for vehicle frontal area divided by 2. Okay. Okay, we go back to the drag coefficient. Okay. This figure shows the change in drag coefficient versus relative wing angle. Okay, they are different vehicle type. Okay, so they are the relative wing angle, meaning that there are several yaw angle. Okay, for example, family family sedan, this is the graph. Okay. So as the wind angle increase, so the drag coefficient also will be increased. It same goes to another type of the car. And then this is the set force of the vehicle. Okay, wind force. And then this is the equation for side force. Okay, when we look into the figure, okay, for different type of vehicle, sedan, wagon, hatchback and van, as the relative wind angle decrease, the side force coefficient also will be increased. And then this is the equation for the side force. Okay, compared to previous slide. Okay, the slide. So this is just change the drag coefficient here. Okay. So this is the CS. CS. Change the side force coefficient. Another term is remain same. And then how about lift force? Same. Okay, same. But this is a CL, lift coefficient. Okay, this is the lift force. And then pitching moment. Pitching moment. Almost same the formula. Okay, PM is the pitching moment. Just change the coefficient. So this is the coefficient of pitching moment. And then this graph shows the variation of pitching moment coefficient with body pitch angle at different type of vehicle. Okay. Okay, how about your moment? Also same. Just change the coefficient here. Okay. And rolling moment. And rolling moment. Sama juga.